Hello all and welcome back to the video lecture of Grade 10 Science Chapter number 1 Chemical Reactions and Equations, and this is Lecture 5 Redox Reactions Part 2. If you have missed Redox Reactions Part 1, then the link is in the description box. Kindly go through that video and come back to this one. In this video, you will be able to understand something more about redox reactions. So let us begin with the help of an equation. This equation is zinc reacting with HCl to form ZnCl2 plus H2. The first thing you must have noticed that this equation is not balanced. So let us start by balancing the equation. On the product side, hydrogen and chlorine both have two number of atoms, but in the reactants, it is only one for each, and hence we will write 2 for HCl. Also, let us mention the physical state. For zinc, it is solid. For HCl, it is aqueous state. For ZnCl2, it is aqueous state. And for hydrogen, it is gas. Brilliant. So this is the balanced equation for Zn and HCl. So tell me, students, this is which type of reaction? Yes, this is an example of a single displacement reaction. But what if I tell you that this is also a redox reaction? Even if there is no removal or addition of hydrogen or oxygen, still this is an example of a redox reaction. So let us understand how. We will understand this with the help of the concept of charges. We all know that ions, they have charges in them, that is positive and negative charge. So now let us start by writing the charge on each element that is present in this equation. For zinc, as it is in the elemental form or the natural form, or it is not combined with any other element, the charge on zinc is 0. For HCl, we all know that HCl is made up of two types of ions, that is H plus and Cl minus, isn't it? So the charge for hydrogen is plus 1 and the charge for chlorine is minus 1. Similarly, let us write it for zinc chloride. For zinc, it is plus 2 and for chlorine, it is minus 1. If you are unaware of the charges, you may go back to your grade 9 chapter number 3, wherein the charges of each element is given. Now for hydrogen, as hydrogen is in the elemental form, in the natural form, that is, it is not combined with any other element, hence the charge on hydrogen will be 0. Now let us compare the charges for reactants and the products. Okay, so we are going to compare the charges, means what is happening to the charge, yes, for the reactant side and same for the product side. Now here zinc, yes, here in the reactant side the charge is 0, but in the product side the charge is plus 2. So we can say from 0 it is changing to plus 2. Or in other words, we can also say that the charge is increasing, isn't it? Okay, so this is what we have observed for zinc. Now let us write down for hydrogen. For hydrogen, in the reactant side it is plus 1, but in the product side it has changed to 0. So from plus 1 it is changing to 0. or in other words, we can also say that there is a decrease in the charge. Whereas for chlorine, for the reactant as well as for the product side, both it is -1. Isn't it? Yes. So now let us go to some conclusion. So students, whenever the charge is increasing or there is an increase in the charge, we say that the substance undergoes oxidation. And whenever there is a decrease in the charge, we say that the substance undergoes reduction. So here for this equation, we can say that zinc is undergoing oxidation, whereas H or HCl is undergoing reduction. Or in other words, we can also say that zinc is the reducing agent, whereas HCl is the oxidizing agent. And hence, this example or this equation is a redox reaction. So redox in terms of charges, whenever there is an increase in the charge, it is oxidation, and whenever there is decrease in the charge, it is reduction. So students, let us understand few more equation examples. Okay, now this example is here in front of you all. That is Fe plus CuSO4 gives FeSO4 plus Cu. Again, a single displacement reaction. So we will first begin by writing the charges. Okay, so for Fe, again in the elemental form, the charge will be 0. Copper sulfate, the charge will be, for copper, the charge is +2. For sulfate, the charge is -2. Then in the product side, it is ferrous sulfate. For ferrous, the charge is +2. For sulfate, the charge is -2. Whereas copper is in the elemental form, the charge will be 0. Again, now let us compare. So here, as you can see, Fe, the charge is changing from +2. The charge is changing from 0 to +2. So there is an increase in the charge. Very good. So whenever there is increase in the charge, it is oxidation. Or we can also say Fe is the reducing agent. Brilliant. Whereas CuSO4, that is for Cu students, there is a decrease in the charge from +2 to 0. So here we can say CuSO4 is undergoing reduction. Or in other words, we can say CuSO4 is the oxidizing agent. Brilliant. And this is how Fe plus CuSO4, this equation, this reaction is a redox reaction. Let us proceed to our next example. So this is a double displacement reaction. Till now, the two examples that we did, they were single displacement, isn't it? Fine. The same thing we are going to start. We are going to start by writing the charges on each element. Okay, so this equation is HCl plus NaOH gives NaCl plus H2O. Yes, a neutralization reaction. So HCl, the charge on hydrogen is +1, on chlorine is -1. Sodium, the charge is +1, and OH, the charge is -1. Similarly, Na, again the charge is +1, Cl is -1, and H2O, it ionizes as H plus and OH minus. So it is +1 and -1 for OH. Okay, it will dissociate as H and OH, H plus and OH minus. So these are the charges for each element or ions respectively. Now students, if you have noticed here, for hydrogen +1 in the product side also +1, Cl -1 in the product side also -1, sodium OH +1 -1 +1 -1. So basically what is happening for a double displacement reaction, that there is neither increase in the charge nor there is a decrease in the charge, and hence as there is no increase or decrease in the charges, we say that double displacement reactions, they are not an example of redox reactions. So now let us summarize it. Till now we have studied oxidation, that it is addition of oxygen, removal of hydrogen or loss of electrons. Now one more point we will add, that oxidation is increase in the charge. This charge we can also call it as oxidation number. And oxidation number is the charge on the ion. Okay, yes. Now students, more about oxidation number you will be studying in standard 11. Okay, for now just understand that we can also call this charge as the oxidation number. Similarly, for reduction, we have studied that it is addition of hydrogen, removal of oxygen or gain of electrons, and it is also decrease in charge or decrease in the oxidation number. So I hope you all have understood this topic. So with this, we complete redox reactions. Thank you so much for watching.